everyone, I'm Roman from Curve. I'm doing smart contracts for Curve. So Curve is deployed over 20 networks already, and there are more coming just the moment we speak. New chains actively want us to deploy there to bring liquidity and ecosystem for the growth. But Curve DAO and core Curve projects live on Ethereum, so all these chains need some data and governance messaged from the Ethereum. There are mainly two categories of the cross-chain messaging. First is native bridges like Optimism. There is a solution on Optimism for layer 2s, or Sonic has also native bridge, and they have zero extra risk apart from the protocol, but there is no standard for the bridge, so you have to maintain every solution separately. There are also some transport layers above the chains, for example, LayerZero and CCIP, which are most popular, but they have extra risk. However, you have one solution for all the chains. Being taught by multi-chain incident back 3 years ago, we are trying to minimize the risk and decentralize all the breaches. So if one breach goes off, all the other chains are still functioning, and there is no liquidity at risk. So the best solution for us was to make blockhash or state root storage proofs. How does it work? We use some transport layer like native bridges or the LayerZero to transport blockhash to the other network. Then users or the keepers provide the data with the needed proof to the verifiers, and then all our apps can use it. Have access to this data. This is good for governance, so we can own contracts on other networks from the Ethereum. We have token prices that are actively updated for SCVUSD, and we can set up different things from in one entry point on Ethereum. At Curve, we exclusively develop on Vyper, but Vyper lacks the dynamic array allocation, so it's not efficient to write on Vyper these storage proofs. That is why we decided to go with Solidity implementation using the widely used library, and we discovered that there was a critical vulnerability with millions at risk, and we contacted chain security. They coordinated the group channels, proper disclosure, and helped to mitigate the risks. This was applicable for Aave, Frax, and StakeDAO. Now everything is fixed and safe. So now going deeper on the storage proofs. Blockchain consists of different blocks with the headers, which are hashed, becoming a block hash. And one of the fields is state root. So given a block hash, you can verify the state root value. So we reduced the tasks from proving for the block hash to the state root, so we can have either of them. So on the slide, you can see some example of the account tree, storage tree, Merkle Patricia tree with the root on the top, and several nested branches going below. So what is the storage proof is the path from the root to the leaf node or to the absence of the leaf node. So there will be a hash of empty node. This way, you provide the whole path and the proof that there is a certain value in the storage. So what was the bug? The library didn't check if the next node is actually provided in the proof. So the default value was 0, and it returned a 0 value for the storage slot. And you could provide a 0 value for Oracle price, for example, which then crashed all the system. So we did a lot on these storage proofs at Curve, and we want to help others with it. First of all, we rewritten the LayerZero standard library that is more than thousands of lines of Solidity code to Vyper. So it's undergone audit now, and any Vyper project can use it by the link. And also, we're deploying our oracles to all the chains we're deployed to. We're using native bridges where possible, and LayerZero for layer 1s, and for new Curve-like deployments that need to be deployed now, so we can update the storage native bridge later. We're using LayerZero to use custom deviants, so we are having in-house Curve deviant, and later we will add CCIP, Axelar, and other bridges through Curve consensus validator. And this one is available for everyone. So if you're doing some multi-chain application, you can use our oracles to solve the same problems that we had with governance, oracles, or anything. And especially if you're integrating Curve, you have no extra risk, because this is already the risk that's connected to the Curve protocol. I was really fast. So if you have questions, I can ask. I can answer.